Aloha class, welcome back. Hope you had a great summer. Welcome to AP Calculus A, B, and BC. We're flipping the classroom this year, which means I'm making up all these awesome lessons so that you can pause when you don't understand something, you can hear it again. Or one of the best things is if you miss class, you don't really actually miss a day and you can keep up to speed what we're doing in class. Always bring your questions to class. Always pause and go back. Take great notes, okay? And most importantly, work hard this year. Okay, the goal this year, let's get that 5 on that AP exam at the end of the school year. All right, here we go. We're going to start AP Calculus here with Chapter 2. Okay, and have a couple things here actually from the College Board that I want you to go ahead and look and make sure you're paying attention to. Okay, the first and foremost thing would be, hey, we start out with enduring understanding. Calculus allows us to generalize knowledge about motion to diverse problems involving change. Everything in this world is about change. Okay, whether we're dealing with the stock market and our money, or we're dealing with our satellites in outer space. Everything is about change, and that's the beauty about calculus. It brings everything we've ever learned in the math classroom into light and into fruition and can teach us how the world works every day outside, which is pretty darn cool if you're really thinking about it. Okay, I'm just going to go over one thing. Our objective here in this first lesson is to interpret the rate of change at an instant in terms of average rates of change over intervals containing that instant. Now, what I want you to do is look at the essential knowledge. You can hit pause, look at that, and then we're going to get started with a lesson. Now, you should have got notes in class. Okay? Your first piece of notes looks like this right here. We start AP Calc with the average versus instantaneous velocity. Now, what I want you to do is I want you to hit pause here in a moment, and I want you to read, let me get that pen there. I want you to read those first couple of paragraphs and example 1. I'm going to take this little video thing out of here because I'm sure you're already sick of looking at me. I got these crazy headphones on. I'll bring it on from time to time because supposedly you're supposed to put it on there to help personalize these lessons. Okay, but go ahead and give that a read, hit pause, and let's get started with the school year of AP Calc. All right, here we go. Wild E. Coyote's chasing the Roadrunner, fails again, falls off a 900-foot cliff. Well, where is Wild E. Coyote's position during this fall? Well, believe it or not, we could use our little position function here to find out where he is, which would be S of t equals negative 16t squared, some gravity involved there, plus his initial height. Well, his initial height was 900 feet. What if I wanted to find out what Wild E's average velocity was throughout the first 3 seconds? Well, that is simply his displacement, which is our change in position over those first 3 seconds, all over his change in time. Now, bust out that TI-84 calculator, plug that bad boy in, and you should get negative 48 feet per second. Let's always use units here whenever we're doing anything in AP Calculus. That gets very important as we get ready for quizzes and tests, and most importantly, that AP Calc exam at the end of the year. Now, what's Wild E's average velocity from t equals 2 to t equals 3 seconds? Well, that would be s of 3 minus s of 2 all over 3 minus 2. Kind of getting this? This is how we can always find average velocity, or hey, that's an average rate of change, which is the difference in the position of Wild E. Coyote divided by the difference or the change in time. You put that bad boy into your calculator, you get negative 80 feet per second. Now, D is a little bit differently. Okay, it's asking us what Wild E's instantaneous velocity is at t equals 3. Nothing to compare that to. The only way I could do this using an idea of average rate of change would be s of 3 minus s of 3 all over 3 minus 3. Something cray happens, right? We get a little 0 over 0. Graphically, it looks like a hole or a removable discontinuity. Now, in able to examine what's happening instantaneously at a value, we need to have the idea and the concepts of what a limit is about. Now, you should have been introduced this in pre-calc last year. If you weren't, don't be alarmed. We're going to take our time and we're going to go over this in detail. Example 2 allows us to do that. Okay, now let's see how we can get to this thing called instantaneous velocity. In order to do that, what we're going to do is we're going to examine average rate of change, or in this case, average velocity, as we get closer and closer and closer to 3. Now, instead of wasting some time and all of us putting this bad boy into my calculator, I got this cool little thing I can do right here as I take my pen and I go boom, bang, boom, and example 2, 3, 4, 5, all done for us because we really just want to notice one very keen observation. Now, if I were you, I'd hit pause and write all these guys down. But if you notice, when we close that gap between 3 and what we're comparing it to, or trying to find the average rate of change between, you notice that these values get closer and closer to something. And that's the whole idea of what we call the concept or the idea of a limit. As you get closer and closer to this value of 3, you close that gap. If you notice, that's darn near 0 over 0, right, class? But if you notice, I'm getting this average rate of change of negative 95.984 feet per second. Now, the question is as I close that gap, and I close it, I mean, what happens between 3 and 2.99999, right? Where do you think that value is going? Or what if I compare 3 with 3.00001? Do you think it's going to go to a specific value? And that's this whole idea of instantaneous velocity and the idea concept of a limit that enables us to go ahead and figure out or have an idea of what's going on. So even though we cannot find the average velocity at exactly 3 seconds, we can discover what while E's velocity is approaching when t equals 3. Now, the question is, you guys are real smart. I know we're just back over the summer, but I guess you have a pretty darn good idea at exactly time equals 3 what is while E coyote's velocity. And if I wrote down those notes from the other page, we all notice that those guys go to negative 96 feet per second. And the idea of a limit helped me to figure that out. Now, that was our introduction and what AP Calculus is all about. In your next video, we're going to actually go ahead and get started with 2.1 and still look at that average rate of change versus instantaneous rate of change, which we will use average velocity comparing it to instantaneous velocity to help give us a better understanding of what's going on. Welcome to AP Calc. Now let's start the next video and really get into the nut and bolts of what calculus is all about.